We should be live. Cool. Let's try this another stream. Today I'm gonna build a minter. So that's kind of website where you can mint a new token. We're gonna do an example of ERC20, so like a cryptocurrency. You could mint cryptocurrency, but it will work very much the same for NFTs. So ERC721 or 1155. That would work very similar. But today we're gonna do Bitcoin, which is a beaver coin. That's a thing we started a few videos. I'm gonna link how we built this contract in the first place. But it's let's actually have a look. It's a very simple contract. It's just based on the OpenZeppelin implementation of ERC20, and we can tweak it a little bit to make sure things work. Before we do that, let's just do a little bit of command line because that's what people love, of course. So we're gonna do Truffle Develop. This will spin up a local blockchain on your laptop or on your machine, and it will let you interact with your contract. So we can say deploy here, and this will compile and deploy our contracts. So right now it did compile and deploy our Bitcoin contract as well. Like for the details, again, look at the previous video. For now, let's just get the contract here. Boom, boom, boom. Bitcoin deployed. Boom. Perfect. And now we can have look at what the total supply of that token is. It's 0, as you can see here. And then we can also mint some. So we can say mint 20 maybe. And we can see that total supply is 20 now, and then balance of accounts 0 is 20. But accounts 1 is 0. So why we're using these accounts is that at the beginning, when these develop environment starts, you get like 10 accounts, or I think it's 10. And then you can use them for stuff. And if you don't specify account, like we haven't when we did the mint, it's gonna assume you're using account 0. But we can also say from accounts 1. And this failed. It says only for me to call. And if we look at the code, whoops, here, that's because the mint has this require here, which is checking that the owner is the sender who's like calling the mint function is also the owner, so the person deploying the contract in the first place. So this is what we've done in the first place. But we, while I wanted to demo this real quick, is that we're gonna change how this minting function works. Cool. So one thing to note is that ERC20, the one from OpenZeppelin, doesn't come with exposed mint function, which kind of makes sense because this part is really hard to standardize. Each project will have different rules and, you know, kind of price for the minting itself. So that's why it's not part of the implementation itself, and not part of the interface either. So it's a function that you need to build out. So right now we have this mint function that we built that we're gonna change drastically. Actually, let's just drop this whole thing. Let's just keep this. So we want to have a mint function that's gonna generate some sort of tokens. So let's imagine this. Let's have a ERC20 token, Bitcoin, which is gonna be mintable in ratio 1:1 for simplicity. So if you send 1 Ether in, you get 1 Bitcoin back, if that makes sense. You could play some more stuff, like you could have like variable ratio and stuff based on like total supply maybe, or something like that. But for now, let's just do very simple stuff. So basically what we want to do here is we're going to call mint function this underscore mint function that we're calling, this comes from the ERC20 implementation that you can check, but it basically does the minting for us. It will create these new tokens and assign them to the wallet that we tell it to. Actually, let's have a look to see the interface. It wants 2 arguments. It wants a count that's supposed to get these new tokens and how many. So let's go back and let's say that message sender is gonna get some, new tokens amount or something. Cool, that makes sense, I think. And then new tokens amount, we can just say message value here. So what you could do is do some sort of ratio or some other definition how you want to, calculate this. Oh, this needs type. But as I mentioned, for simplicity, let's just go with this. Now this is squiggly line because, yes, it needs to be payable. So all the even external or public methods in Solidity that don't have a keyboard payable will fail if you send some ether on it, or like fail if you send a native token on them. Why I'm saying native token, because on blockchain it's Ethereum, but on Avalanche it can be AVAX or so on, right? Because all these different blockchains, they are all EVM compatible, Ethereum virtual machine, so they all work the same. So this is already pretty good, I guess. Yeah, this would work, I think. So let's try that. So if we deploy again, oh yeah, we need to do reset because it remembers. Cool, and then we can do deploy, we can do this, right? We're gonna get another contract and then try to mint some more. We can try to mint and send it from accounts 1, which is this time not the owner, and we can give it some value, like maybe 10, right? And now if we look at this, worked, didn't fail like before. So if we look at total balance, what did I do? Oh, contract 2. Total supply, I mean, you're gonna see that it's 10 ways, right? So this is perfect. I think we can stop here in the contract level. What you probably would want to do is to have some sort of minimum value here, which you could do, like, message value is higher than something, right? Ether. Right? You could do that, but let's not complicate our life. You could also make this value configurable only by owner, so that, that changes. But let's just keep it simple. So we have this. So this is perfect. Yes, next up, let's start building the thing. So our contract is ready. When we're gonna need it, we're gonna deploy it on Rinkebi test network, so we can interact with it. But we're also gonna build like a front end for it, which is the main point of today's video. So let's, in the terminal down here, I'm gonna write, or let me do it in the bigger one. So we don't need the develop, so we can get out of here. But what we can do here is we can say npx create react app template TypeScript. You obviously don't need to use TypeScript, but I do. And then a folder you want this to be created. So let's call it frontend. Boom. This is gonna take a little while. This is this terminal is actually in the same place here as here, right? So that's why this works. and it started to create this front end folder that you can see here already. Just gonna get rid of the terminal so it's more cleaner. And it's building its thing, right? So why I'm doing TypeScript is because I like types. Because I think it makes the development process faster. You get faster feedback, you fix the problems sooner, so it's just nicer. And why I'm using npm instead of what's the YAML? No, I don't know. The default one is just because I'm used to npm and I know the commands. Yeah. Same like last time, I'm gonna use Bootstrap, which is CSS library, just to make it a little bit nicer than just the base HTML, and because I don't want to deal with the CSS really, because it's, you know, that's not the main point. Also, what we're gonna do, which is kind of hard, because it's a lot of steps that we need to do before we get to actual minting, is just validating that the user has Metamask plugin, that it's all correctly connected, that it has a correct network, and so on. So we're gonna skim through some parts of it, like we're gonna build some validations, but you probably want to build a little bit more. Like you probably want to have some automated way to create, to create some more stuff. Cool. So now it finished building. So if we go to front end and do npm start here, it should start something on port 3000. It should open your default browser, but you know, this is the cool thing. So now we have that. Yes, I'm gonna kill it now because I also wanted to install some stuff. So I said I'm gonna want Bootstrap, and also what we need is Web3, because that's the library that we're actually using to connect to blockchain. So boom, I'm gonna add those two there. While this is happening, I'm gonna mention one more thing. Web3 has currently some compatibility issue with Web3 library, that is Web3.js, has compatibility issue with the latest Create React app. So we will have to downgrade it when it comes to it. I mean, we will have to downgrade Create React app. There are some polyfills that are not there. So we'll see how that goes. Hopefully nothing too painful. Cool, so now it's finished. Let's go back to here. I'm gonna start it from here so we can look at some compiling errors if we need them. Yes, we need to go to front end. Boom. Cool, this should work. So if we open this again, yes, this works. Let's make it side by side so you can see what's happening, although this is not awesome, but hopefully it's gonna be okay. And let's make it a little bit cleaner. So let's, there's a bunch of files that were generated by this templating software, Create React App. We don't need to go too much to them. API app DSX is the main one that we want to go in. Yeah, so let's just start here. We don't need any of that. So if we delete that, you see we lose everything. Oh, maybe let's keep that. I like the background. Was that a header that is doing that? Yeah. No, actually, let's just get rid of it. So let's say something here, something. No, we should get something. I think there's a background arc. Is that a thing? No, maybe not. Okay, this is fine. We can make a container. And I don't know, padding 4. Oh yeah, this doesn't work because I forgot to import the CSS library. So the npm bootstrap will install it, but we still need to include it to our folder, so that stuff starts to happen. Yeah, so can we try that background dark? No? Yes, horrible. Let's not do it. Cool, so now we have a basic app and we can start building. So first thing we want to do is to figure out if the user has Metamask plugin or not. Because we're gonna need that one. So to check if there is one, one cheeky way to do this is, let me get rid of that as well, is check if there is a given provider. So what the Metamask plugin does, out of its good heart, is to inject this given provider field right here. And that's when we did the reading thing for NTM NFTs, what we've done, we used the Infura node to actually get data, right? So that was really cool. But when you're interacting with Metamask plugin, it has its own connection to Node. I think it's using Infura as well, actually, but it has its own connection. So you're not using your, the Infura link that you've built. You're using whatever Metamask is doing, so that you can use Metamask to send transactions. I guess this is a little bit confusing, but the summary is you don't need Infura if you have a plugin directly. So I guess what we can do is just console log what Web3 given provider has. Boom. Oh, if I know how to type. I think this is the point where things go boom, if I'm not mistaken. Yes. So this is the compatibility problem that I talked about. And to fix that, we're just gonna go to the current package.json in front end here. And there are these React scripts, and these are 5000, which is not compatible version. So we're gonna just downgrade them to 4.3. And then we need to do npm install here. I'm here down in terminal, typing npm install, which will change the versions. So we will get 403, because that's the version that still works fine with Web3. Sorry, I'm drinking the tea and now I realize it's probably very not fun to listen. But that's life. Cool. Let's see if I can get that. How do I move this down? Like this, right? Nice. We don't need that. We just want that. So let's go back to here. Perfect. And now if we do npm start, if I know how to type, it's gonna do magic. So if we refresh here, hopefully. Oh yeah, it didn't finish loading yet. Just took impatient. Nice. We don't have that error anymore. And now we can see that we got some object here. Let's have a look how that looks like in incognito window. Incognito window doesn't have access to your extensions, so it will not have that plugin in there. So you can see we got null here from this line. Cool. So, and what I've done here is just convert this object to a boolean. So one question mark exclamation mark is negation, so from true to false, and the second one will convert it back. But this is a short way to converting whatever, like in this case it's an object or null, into a boolean. Cool. So now if we don't have a, let's name it have provider. If we don't have a provider, that means the user doesn't have Metamask, right? There could be different plugins or different wallets, but for simplicity, let's just call Metamask because that's just what everybody's using. So let's, in this case, return a different, how's it called? Component? Yeah, component. That we're gonna write down here. Like in the real life, you would probably have a different file for this. But for our sake, let's just write it right here. And then we're gonna return something like, yeah, whatever, container diff. And we can put h4. Please install the wallet. So this is good. Oh, we have this warning about logo. Oh, let's ignore that. This is good. You see that here on the side which has the plugin, we're still seeing the something. But if we look at, what is this? Right, we got this side. And this is the incognito window, which doesn't have the wallet. Again, and then if you want to be super nice, you can put a button, right? Something like button primary, get Metamask, and then fetch, what's it called, Metamask, like link it to Metamask website, whatever. This is good. Let's steal that. And then here we can say a ref, boom, boom. Cool. And then if you refresh this and click this, we will go to Metamask. Perfect. So this is good. Now, let's continue further. So now the user, we know that the user has Metamask if we get somewhere here. But next up, if you probably where it is Metamask, there are several networks the user can be on, right? And we need to make sure that the user is on the correct network that we want. So how do you do that? So let's do that first. How do you check for that? So to check for that, you would have to have a web-free object that we can construct. That's easy. And then you call net ID on it. So let's do that. So, but the problem is that whenever that, let's do that. So what we can do is, get a web-free instance by calling web-free like so, and then we're gonna give it a provider, which is this given provider. Seems kind of arbitrary, but that's how it works. And then what you can do, is it on ETH? I forgot. Okay, let me check my cheat sheet. Oh, it's that. All right, sure. So it's net get ID, obviously. And this is async call, so let's just do net ID here. And just console log it. Ooh, boom. Perfect. So you see we got net ID 42. But the problem here is that if the user goes here, right, and changes to like Rinkaby, say, we don't get the we don't run the component again, so we don't know that the user checked this, because this is not like a hook or something. This is just us calling once. So what you can do, which is very bad, well, that's one version of doing it, is just have an effect. And in that effect, we're going to have an interval. So let's do that. Have provider, boom. I guess it should be has, but who cares? So we only want to do it if user has provider, otherwise there's no point. And what we can do is do interval, set interval. So this is pure JavaScript, right? And because React is pure JavaScript, you get to do these kind of things. So we're gonna do some stuff here, and let's say we're gonna run this every 4 seconds. Why not? And every 4 seconds, well, what we're gonna do is we're gonna do this. I think that makes sense. No, it isn't. It's not doing it. Oh yeah, it is. 1, 2, 3, 4. Cool. So this is maybe too slow. So let's set it to 1 second. Cool. So now we're getting them, right? If we would change, if we would, if I manage to click this guy, I guess I don't need to click it. Right, that's the thing. If we check it to something else, you know, we get a different ID. But now what do we do with this? One thing I forgot to mention, you probably want to return here, remove interval or clear interval. Yes. So that's just so that, you know, stuff doesn't get updated if it doesn't need to. That's more React stuff, so that's not too important to us. So now we need to get this ID outside of this loop, right? So because we want to here do something like, if it's a wrong ID, do something. So how we do that is that we use state. Let's do net ID here and set net ID. Boom. Use state. And then let's say 0, I guess. This makes sense. We need to import useState. And then when we get net ID, let's just set it here instead. And that should stop the console log. And now here we can say console log net ID net ID. Actually, let's see if it keeps updating. Oh, it does. Cool. So I'm thinking maybe let's just do, let's just update the state if the net ID changed, so we don't get that many redraws. Let's see. So what we would do is if net ID is different. Oh, okay. So this needs to be new and new net ID because we already have a net ID. Boom. If it's different than the existing net ID, then we're gonna set net ID. That makes sense. Maybe. Let's see how this goes. It still keeps coming. Bye. Or maybe I just need to refresh. Maybe I'm just... Yeah, now it stopped. I wonder if it was the refresh. Maybe we don't need that condition then. Yeah, sure, it doesn't work. It works, like it stops because new net ID doesn't change, so we didn't need that condition. Cool. So we're happy with this. Next thing, so we need to check that this is ring-cabby. For that, let's check what the correct ring-cabby ID is. I think it was 4. Yes, ring-cabby is 4. So let's do some constant here. Ring-cabby net ID equals 4. Boom. And if net ID is not equal, ring-cabby test net ID we're gonna return switch network page, which makes sense, I guess. Boom, 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 boom. And let's create a new component here. Let's just call it switch network. Let's steal this and call it please switch network to Rinkaby. Yes, and then if we've done this correctly, if we go to different wrong network, like a mainnet, it's gonna tell us to switch. And if we switch back to Rinkaby, we're back here. Perfect. So one thing to note is that you probably want to do, if you're in the wrong network, what you can do, there is a way to inject the network you want into Metamask. So you want to have a button saying click the button, and it's gonna make sure that the Metamask is configured to the correct network. But you know, do that. We're not gonna do that now. Awesome. Next thing, as you saw when we were interacting in the develop scenario, you need an account to send from. If we look at Rinkaby and the Metamask plugin right here, you can see I have this one account. I think I have just that one account, yes. So we need basically this address of this account that we want to use, right? So to get that, this gets a little bit tricky, but yeah, let's get it first. So basically it's again where we need this web3. We need to do it here again. So we're gonna every 1 second ask for the account if they change or not. And how to get it, you do web3 with get accounts. Yes, this is it. And again, this is async, so we get accounts. And then we can do stuff with the accounts. So for now, let's just console log it. Yep. Oops. And now we're getting empty array. So why are we getting empty array is because for this to work, we need to connect the account to Metamask. So whenever you're interacting with whatever application that does blockchain stuff, like some DeFi project or some crypto game, they want you to connect, so-called connect Metamask. So that means that you give access to your accounts to that application. That does not mean that you share a private key with them. That just means that they know about the accounts that the MetaMask has access to. For each transaction, they will still open a new, window asking you to confirm. So that's not something, dangerous to connect your account. Although you do give them some sort of, control. Anyways, so let's do another state here for account. Boom. And set account. Boom. And a new state. Let's make it empty string for now. We can figure this later, but let's, for now, if we don't have account, right, let's do another thing, which is gonna be connect. So we're gonna do this connect page. Yeah, let's do it here. This makes sense, I guess, to me. Why are you not? Oh yeah, because we're not returning, so let's just do that, as you saw me do a few times. So it says this, but we need to say something else. We need to say, please connect your account. And probably you want to give them a button to do that, so let's give a button. Boom. Yes, yes, yes. Connect. The awesomeness. I don't know how to spell that. This way? maybe. Cool. And then we need to, have a handle connect. That's gonna do something for us when the user clicks this. On click, boom, on click. Yeah, let's just console log this to be sure. We should get rid of that annoying console log, right? Let's comment this out. And then, yeah, connecting. So whenever we click that here, we should get connecting. Super cool. So how do you do that actually? How do you do the connect? So what I would do, I would just Google for it, right? Connect Metamask, boom, or DuckDuckGo it. No, it's no. I know what I'm looking for. It's none of these links. I think we should write Web3. Maybe JS to understand that we mean like programmatically. Yeah, I think this is the good article that I read. So you can read this, but basically what you want to do is to... you don't need that, you don't need that. We need this. Actually, I think it's, yeah. So to do that, we need, again, you could do what they're doing, probably. But you can also do that you get an instance of Web3, same way we've done above, inject the provider, boom. And then you can do Web3. Well, actually we don't need that, right? Web3 instance. We just need given provider, and then that thing has ETH. And then you can do the request on it. I think this should be it. So you say request accounts, and that's what you send to this given provider. Hopefully that's gonna work. I don't know. Let's see. No, it did not work. Okay, so I'm gonna check my secret notes. How did I did it last time? Boom. Okay, so it's much simpler than that. You just say send. I guess there are multiple ways how you can get this request to MetaMask, but this seems to work. No, it did not work again. God damn it. What am I doing wrong? Oh yeah, it shouldn't be in the method. You just do that. That's weird. Third time's the charm. Boom. And now it, kicks in, asks you for the account you want to use, and you say boom, perfect, connect. Now it's connected, but we're still here. Why we are still here is because we didn't do anything with the accounts we're getting back. So if we uncomment this accounts logging thing, you can see that now we're getting accounts in this array. So what we can do, we can just set account to be the 0th, and because this can be undefined, we're just going to put empty string so that it's still falsy and it goes to this place. But perfect, now we're nearly there. So we got most of the difficult stuff out of the way. Now we're here on our page, and we can write something here. So let's do that. So we can say H2, your great life savings, something. And then let's create a div here. We can make it cart or cart. Yeah. And yeah, let's just say account and we can inject the account. Balance is, and then somehow we're gonna fetch the balance first. Hi, this looks good. This card can use some padding, maybe one. And let's make it more colorful. So account, I'm gonna make account blue. Now, how do we get balance of an account? So we can do what we can do. Yes, let's do it. So we can create another effect here that basically changes whenever account changes. That's a good strategy, I guess. And then if we have account, we're gonna do this craziness. So we need this Web3 provider. Boom. We also, next up, we need to get linked to our contract finally, which we do by doing new Web3 contract. Yes. And now to do this, we need two arguments to contract. One is the ABI, and the another one is address. We don't know any of those things. So first up, let's get the ABI. That's not too difficult. So you can do new file. Let's call it whatever. Bcoin. ABI. TSX. TSX, fine. And then when we have a truffle, which we do, whenever we compile contracts, it creates this build folder. Inside this is this Bcoin JSON, and this JSON describes the contract. It includes many things, including the binary that's going to get deployed somewhere, the bytecode that's going to get deployed on the chain in the end. Sorry, I'm just skipping around like crazy person that I am. But it also has this ABI. ABI is basically a description of that interface, of that specific contract, so that it knows what kind of method it can call on them. For now, let's just put it here. I'm gonna do SNE, which is not important, but it's just TypeScript thing. Yes, this looks good. Oh, and we wanna export it as well. And then back home, we wanna get this ABI. Boom. Next up, we need the address. To get the address, we need to first deploy the contract. So to do that, we're gonna just run, okay, we need to go out here. So we're again in terminal here. And what we're gonna do is we're gonna do truffle deploy, but we're also gonna tell it to deploy it to Rinkaby network. And we're gonna say reset because I did deploy there before. The Rinkaby points to a configuration in truffle config, which tells it where to find the Rinkaby network. But basically, just connect to the correct place and starts deployment. So let's wait for that. And what we're after is the contract address of the Bcoin contract. But this is the migration contract, which comes with all the truffle deployments. But the next one's going to be cool. Next one's the one we want. Exciting. Yes. So this is fun, right? Blockchain stuff. We're deploying stuff for ages. Everything takes time and money. This is how the future looks. No, but it's kind of nice. Like, we understand the complexity, right? Because now it needs to go to all these nodes, and which is what makes it secure and very interactive. So we get to copy this contract address from Bitcoin, which is what we wanted. And now we can use this here. Perfect. So let's get rid of that. So now we have a contract. What we get to do, we get to call contract the methods and then balance off. Oops. And then we can save the account. And then we call. So this is read method, right? Balance off. We don't need to sign any transactions to read it. We just call it, and then we get a result, hopefully. Let's, console log the result. Horrible formatting. Why are you complaining? Oh, it doesn't have type. That's, who cares? Cool. And as you can see, we got result 0, which is correct. So let's store that somewhere so we can show it here, right? So let's do balance and set balance and use state. Yeah, let's do number. Why not? I'm going to talk a little bit about why number is a bad decision to do. But let's try this. Boom. This is good. And then down here, balance is this. So let's add one more span here, which will include the actual balance. Am I saying balance correctly? Whenever I say it, that feels like I'm saying some French word. I don't know. What am I doing wrong? How did I mess up? I messed up. Cool. Now we have the 0 here. Very nice. Yeah, hey Ashley. Now I can see a chat. I'm a very profi streamer, as you can tell. So, hey. It's great that you find this fun. Cool. So now we have a balance. And let's do the magic now, which is we need the button. So that button is to mint, right? This is not good. I want this in the cart. I also want it to style some more okay-ish. So BTN primary. This looks good. One thing to note though, as we said, we're gonna what we're gonna do is convert the Ethereum or whatever the native coin to the same amount of our tokens. But to do that, we need, ability for the user to put in how much coin they want to convert. So let's do that. Let's do type number. Yeah, looks about right. Was it form control? To make it nicer? Yes, this looks good. So let's do that. And let's create one more thing here. Let's call this mint amount. Set mint amount. If I get to type this correctly. Use state. And let's kick it off on like this amount, maybe. Right. And then if you've done React inputs before, what you do is you set min amount here, and then on change, let's do a new line. On change, if I dare to spell this, we're gonna set mint amount to e target value as number. Value what? Value as number. Cool. So now this should still work sometimes. If we change this, yes. We can do one more fancy thing and do step equals 0, 0, 1. So that way, If we come here and do arrow up, arrow down, it's gonna do correct steps. One last thing. Let's make it brief a little bit. Ooh. Make it a little bit spacier. Cool. Perfect. We're nearly there. So now when we click the mint button, what we want to do is on click handle mint. Cool stuff. And then let's implement that method. Nice. What we need again is get the contract instance. You probably could make it smarter so you don't need to copy that code, but this works for us. And then methods. There's this mint method that we've done. As a parameter, it wants nothing, I think. Let's double check that. If we go to Bitcoin, right? Mint accepts no arguments, so we don't need any arguments. Those are for losers. But instead of call, we call send, because this time we need a transaction. And sends take this object of 4 parameters, and you say many things, but one of it is from which account you want to send, and value which amount you want to send. So you could send. Let's try that. Let's just put in the mint amount. Right? So if we click mint here, hopefully, oh, it failed. Oh yeah, it fails because it doesn't write like numbers. We can do this. So value is expecting big number, which is not a normal number. Yeah. I was going to show you a different type of error, but let's just not do that. So instead, what you should do, oh sorry, my phone is ringing. What you should do is get utils here and do two-way, because all the amounts that you're sending transaction with needs to be in way. Way is the lowest denominator of the currency. So it's going to be 1 and a lot of zeros behind it, not like this. But for the user experience, we want them to be able to, use human readable numbers. So this worked this time. It triggered this. It will fail. This pop-up shows you that it's going to fail, so you shouldn't even try, let's not try. But why it's going to fail is because if we look at our account, there's like nothing in it. So we probably want to get some ether in here, which we can do. There are a bunch of faucets. Because it's a test network, you get to get a faucet. This is like the official one or the main one, but it was down for a while. There's one that Chainlink has, so let's go there instead. Let's try this one. You put the address, so did I put the correct address? Whoa, I messed up. Oh, here we go. Copy the address, put it here. I want test ether, and I'm not a robot. Now it's doing a thing. But then, if it would be a real application, what you do, you go to Coinbase, right? Purchase some Ethereum, and then you lose it all. That's how this works. Oh, now I see your question. What coins are you invested in? Oh, I'm not invested really too much. I would say in Ethereum, it's pretty good. It's my safe bet because it's more, coding stuff than Bitcoin. But here we go. We got the ether from this faucet. So let's try again. Let's get rid of this. Okay, that would burn all our ether, so let's do this instead. Cool. You see, this might work, so we're gonna do confirm. And now it's gonna take forever. And then it's gonna fail. No, hopefully it's gonna succeed. But there's one more thing I wanted to show you. If this succeeds. Like in the best case scenario, you would have some automatic way to, update this balance. But for now, I'm just gonna press F5. But you see, it shows the number in the ways, which is not that human-friendly, readable. So to fix that, where did we fetch the balance? Here, we catching the balance here, and we set it here. So then, somewhere where we're showing it. Oh yeah, we're showing it here. So here, again, there's a contra converter to two-way, which is from way. So under utils, I don't know how to write. It's from way, and we're gonna say balance, and we're gonna say ether. Now this is a number, so it's not happy. Again, we're gonna do the trick to convert it to string, and then I'm gonna need to learn how to spell ether. But here we go. That's our, that's the end. So now we get the balance. You get to mint, and as I said at the beginning, to mint an NFT or something, you would do very similar thing, like really similar. You would just not show the balance, but you would show the NFT. Yeah, that's it. So if you have any questions, do it now. Otherwise, stay silent. I'm gonna upload this video to YouTube and link it to the one where we build the contract in the first place. Maybe link it to that other one which we show the NFTs, because that's kind of related. Cool. This was fun. Thanks Ashley for joining, and see you next time. If I figure out how to stop this. Bye.